Hello and welcome. So today we'll be looking at the experts level challenge in the first series of the Adebayo Network challenge. So we'll be doing a walkthrough on the solution. So let's just start the devices now. So this lab is the hostile takeover, and you can of course download these documents on the website and go through it and probably even test your hands on the lab. So one thing I'm just going to mention is that all this information we have at the beginning here, they are useful information that will help you in the lab. Just as we saw how this switch was in the foundation craft when we wanted to decide the point-to-point interface on the routers, on the HQ router and the branch router. When we want to decide if it was /30 or /24. By good design, we just default to /30. But what was actually needed was /24. So it's good to refer to this also. Additionally, I noticed in one of the submissions, normally we have the route reflectors here, just as was stated here. The NC core 1 and 2 are the route reflectors. I think I saw a solution that kind of moved the route reflector here, even though that might be fine, and everything still works, but it's not the intended design. It's not intended design. So this information we have at the beginning are useful information that we might want to go through at the beginning or refer to when we want to make a critical decision. Okay. Let's just jump into the main stuff. So before you start, connect to end devices, to end users to the switches. I've shown the topology, but I think I've done that already. These are the end devices. So yeah, these are the end devices. Let me just name this LC, NC, right? I think this is NC. Yeah, and this is legacy core. Okay. You need to do some configuration like setting the IP address of this device. I think I've done that, but if I've not done that, we'll do it together. Then you also answer everything in the answer.docs document. So that's very important. You answer in this document and just convert to PDF before submitting. So we are going to answer one of the prompts together, just the way you should do it also, so you can see how to answer before submitting. Okay, so prompt 1.1 says an audit of our external BGP sessions showed that while pairing with ISP router 2 is established, we are not receiving any prefixes. Investigate the root cause and resolve the issue. Okay, so let's jump into that. Let me just console into all nodes. I'd like you to come here. Okay. And I would like the integration router to come somewhere here, and the LC core come somewhere here. I'm just arranging it in a way that will be useful for me. Okay, I think this is fine. So while pairing with ISP router 2 is okay. So this should be between NC edge and the ISP router 2. So let's see. So let's show iBGP neighbors. So iBGP, so there should be someone. So first of all, we need to know what ISP router 2 is. So what's this IP? 2.2.2.1, I suppose. Okay, so that's it right here. I think we need to find a way to make this better. 2.2.2.1, right? So we see it's established, but we can't receive any prefix. The prefix is 0. So what's really going on here? Let's check the router 2. Show run. So we see its BGP configuration. It's actually advertising something. So why can't we see it? It's advertising this network. So why can't we see it? Let's check back here and see the BGP configuration here. I don't really like using this because I'm using a German laptop for these videos, and where the pipe is, it's a bit difficult to enter. So I just prefer using the show run and press spacebar. I get the way I'm looking for. Something is strange here. We can see a route map attached to that pairing says block ISP2 in. Let's check what this list is all about. So let's show run block ISP2 in. Okay, it is attached to a prefix list called denial. Wow. And this prefix list is called denial. It's denying everything coming from that position, coming from ISP2. So I believe this should be our issue. This should be the issue. So what we can do is to remove this route map here. We can remove that route map here. So let's do that. So router BGP 6500, right? Yeah. Address family IPv4. No, let me just copy and paste. No neighbor this. Okay, so that's fine. Let's check our configuration again to be sure everything is fine. Okay, I think it is removed now. It is removed. So now let's check if we can actually receive prefix. Do show IP BGP summary. So maybe we have to wait a bit for it to converge. Show BGP or okay, so we can receive the 9.9 now actually. So now you see we can receive the prefix. We can receive a prefix from router 2 from this neighbor, and that prefix is what this 9.9. So that issue is resolved. So we can just come to our answers document. Prompt 1.1, right? We can copy and paste the prompt so we'll know what we are answering. Okay, so fault 1, I think it's just one fault, right? So we can just keep or remove the fault 1. So the device location where we performed commands is on the NC edge, right? NC edge 1. If we have to perform on multiple devices, we can put comma and put the other devices right here. So that's fine. So what's the fault description? So the fault description was that there was a route map on NC edge blocking all prefixes or stopping all prefixes from entering. Let us blocking all prefixes coming from, what's that guy's name? ISP router 2, right? ISP router 2 from entering NC edge 1. Okay, so that's fine. With this is good enough. So the remediation commands we used, I think we used router BGP rather. We used address family. We entered the address family IPv4, right? IPv4, and we said no guy. It's not showing here. Okay, there it is. We said no neighbor this, and that resolved the issue. So this is the correct solution for prompt 1.1. So after we are done with that, we can copy and paste again for prompt 1.2 and fix the issue here and do the same thing. Okay, so I think that's fine. So from our NC edge now, we should be able to reach 9.9. That's fine. Okay, so let's go ahead. So prompt 1.2, our iBGP route reflector design is not functioning as intended, leading to inconsistent routing information within the new COP core. Diagnose and fix the root cause of the iBGP route propagation failure. So we know our route reflectors are on these two guys, NC core 1 and 2. So let's see what's going on here. First of all, let's examine the configuration. Show run BGP. Let's do something here. Show run BGP. Okay. So from our design, you can see right here we have neighbor 5.5 reflect client. So who is 5.5? I believe from that should be NC core, and NC core 2 also says neighbor 4.4 reflect client, and 4.4 should be NC core 1. So let's just quickly confirm that. Okay, we can just check the IP up here. So we can see this is 5.5. This is 5.5, and this here is 4.4. This is 4.4. So they are reflecting themselves. But look at, we have another BGP neighbor up here. There's another BGP neighbor up here that they are not doing anything about. To show iBGP summary. So you see, there is another BGP neighbor that they are not. Oh, I'm on the edge. Wrong device. Show iBGP summary. Okay, so you can see this NC core 1 pairs with 2 guys. 5.5 is reflecting that, but it's not reflecting this for this one up. So we need to configure that, and I believe that's the same thing going on here. Show iBGP summary. That's the same thing going on here. It has 4.4 and 3.3, but it's not reflecting for the second one, 3.3, which is this guy here. NC Edge 1. So let's see how to fix that. Okay, router BGP 6500, I suppose. Address family IPv4. So neighbor, what's the IP? 3.3, right? Neighbor 3.3. Route reflector client. Then on the other end also. So you see, after doing that, this neighbor changed, went down, came back up. Router BGP 6500, address family IPv4, neighbor 3, route reflector client. So it should go down, come back up. So that's fine. Now. So you document that also. So I think that should be good for this prompt 1.2. Then now comes 1.3. I think this was a critical point. In this lab, this particular lab. So let's go through it. External internet routes learned from ISPs are failing to propagate from our BGP core into our OSPF domain. So let's undo that first. So the internet route, the 9.9 learns from this guy. Show IP route. Nope. Show IP interface brief. The 9.9 learns from this guy, and the 8.8, I suppose. The 8.8 learned from this guy. Cannot, after getting to the BGP domain, they cannot now come down into the OSPF domain. Right here we have BGP, and here we have OSPF. And we also have some bit of OSPF running here for our importing, right? So it's not coming down into the OSPF domain so that sense can be shared with these new guys here. So we have to fix that issue. So first of all, let's verify again that our NC Edge can see those routes. Do show BGP or so they can see it, and they are good routes. They are good routes and they are best routes. So of course it's going to propagate in the main IP routing table. So we can see it's their length via BGP on this. Okay, so let's go to our NC core and see if we can see those routes too. Do show BGP or so we can see the routes. But look what we have here. It is missing best. So these routes here would not go into our routing table. Show IP routes, so we can see we don't have any routes for 8.8, network not in table, or 9.9. So what could be the issue? We have to troubleshoot this first, because they are telling us that it has entered our BGP domain, our BGP core, but it cannot go down to the OSPF domain. But now we are saying that it has not even entered the BGP core very well. So we need to fix that issue before we talk about the OSPF domain. So now, something quickly that comes to my mind here in this type of scenario is that is the next up reachable? Is the next up of this stuff reachable? So now, what is the next up? So we can say the next up is 1.1 and 2.2.2.1, which are these guys ISP routers up here. So what it tells me is that this NC Edge here is not changing the next up once it receives these guys, because we can see that ISP router 1 is in AS100 as we saw from here, is in AS100, and this other one is in AS200, which are different ASs, different autonomous systems from the 65000 we already have here. So when we are bringing it into this new AS, we have to tell this guy that's pressing it from the gate, from the door, see, once the signal coming inside, change the next up to yourself, because here this guy is under, you can reach you, but they cannot reach these guys up here, except we have something else, some other form of routing going on that they can reach here. Okay, that's fine, but in this case we don't have that form of routing going on. So this guy needs to change the next up to itself and not just leave the next up to these guys up here. So let's fix that. So on the NC edge, let's examine the BGP stuffs going on there. Section include BGP. Section include BGP. Okay, so let's see. So when pairing with 4.4 and 5.5, which are NC Core 1 and NC Core 2 respectively, it has to tell it that, see, use your next up as me. Use your next up as me. So let's do that. So I think we're already in the address family. So let's do neighbor 4.4, next up self, yeah, and neighbor 5.5, next up self. Okay, so after some time, after a while, this should be fixed. Show BGP, or it's still like this. So let's just give it some more seconds for the convergence. Something else we can do, we can clear IP BGP, right? Clear IP BGP. Okay, so let's check again. Show BGPL. It's still the same way. Okay, so after a while, it finally came up. So we'll see. It's now learning this at its best. It's not learning at best, so it can now input this in its routing table, in its global, in its main routing table. So we see we can reach that now to show IP routes, and we can reach this too via BGP. So now these routes have gotten to our core. Good news. Now let's see if it can get to the NC distribution. So I believe this NC distribution, from documentation we got, runs just OSPF, no BGP. And of course, from the pairings we've seen above, there is no pairing with this guy, so it's probably not running BGP. So we see no, it's not running BGP, it's running OSPF. It's running OSPF. So let's see. Show IP OSPF neighbor. So it has paired correctly with 4.4 and 5.5. That's fine. So can it learn those routes? Show IP routes. It cannot learn those routes. It cannot learn the 8.8 and 9.9. So now let's check something. Let's check if these guys are even sharing that with it, because these guys are learning this from BGP. Are they importing it? Are they sharing these routes with to their OSPF domain? Let's see. Show run BGP. Okay. I think I need to go to OSPF. Okay, so these are OSPF, right? So we see inside our OSPF it's redistributing BGP subnets. It's distributing BGP subnets, but why can't we show run? Yeah, it's distributing the subnets, but why can't we see them? Why can't we see these subnets? So I think that can point our attention to something else. Yeah, so by default, iBGP routes will not be imported, will not be sent, will not be shared into IGP like OSPF or ISIS by default. So that is why these 8.8 and 9.9 routes are not being sent via the OSPF domain. Just as we checked here, we can't see those routes 8.8 and 9.9. So to do that, we have to find a way to tell BGP to redistribute those routes. So we can come to our NC core right here. Router address family. So there's a command we can use, BGP redistribute internal. So using this command, we'll be able to let those routes will be distributed into the internal into the IGP, like into the IGP, that's OSPF in this case. So let's check our routes again, and we can see those routes are present now. Those routes are present now. Let's see if we can reach it. Okay. So we see, okay, maybe I think I'm pinging the wrong IP. Ping 8.8, and those routes are reachable. Those routes are reachable. Ping 9.9, and those routes are reachable. So let's go on. So furthermore, our internal routes are failing to be advertised to our primary ISP. Investigate the full path from the BGP edge through the iBGP core. I believe these routes are already advertised. Let's see. Show BGP all. Okay, so we can see we have this route advertised, and that's why our ping was able to work. Show BGP all. This, okay, is advertised. This is advertised. So for this, I think for this we can come back to it. You know, we have 192.168.1 segment, which is for this, and we have 192.168.2 segment, which is for this. So maybe when we bring this up, when we bring this section up, and if it is not advertised, then we have to check and fix whatever is going on to see why it is not advertised. Okay, so that's that for this section. So let's just make sure we finished everything. Investigate the full paths from the eBGP edge. Okay, from that place we did the what's it called, next up self iBGP core. We did the BGP redistribute internal to the OSPF distribution layer and resolve all BGP policy and distribution issues. Okay, so let's just continue. But let's come into this core router. Let's come into this core router and check something. Let's see how our OSPF is being imported or redistributed into BGP, because that's also something we should cover. Though it's working here, but let's see how it is done. So right here we have the route map here, right? We have the route map, OSPF to BGP. Let's see what the route map says. Okay, prefix list internal. Where is the prefix list called internal? So you see now we don't have any prefix list called internal. We don't have any prefix list called internal. So we need to create that prefix list. So what we might think that why is it we don't have that? So why is it learning? Let's check what we have on this core too. Maybe we have something else here. On core 2 we have redistribute OSPF. We don't have any prefix list. So we don't have any prefix list here, so it will just be distributed. So I believe that's where we are learning all those things from. So even though it is working, it's not optimal. It does not completely answer the question, because the question told us to investigate all these also, even the policy issue and all of that. So right here we see that we have internal. So let's just create a prefix list called internal and give it the internal stuffs we want to be redistributed. So IP prefix list internal. So permits. I believe we want to permit. What's the segment? Is it 1 or 10? 192.168.1 and .2. Okay, 192.168.1. Okay, and .2. Let's just create that here. Okay, so that's fine. So if we check our stuff again, we'll see everything should be mapping properly. Now we have the route map here. When we go down, we have the route map down to internal prefix list, and we also have prefix list existing. So we can do the same thing on router 2, on NC core 2, just to be sure everything we are in control of everything. So if we have 100 prefixes down here and we want to import just these 2, we can import only these 2 instead of allowing this guy act rogue like this and importing everything. So let's control that also. So first, I don't know if we have the route map and the prefix here, so let's check. Do show run. We don't have it here, so let's create it. IP prefix internal 192 permit 192.168.1 segments, and also permit.2 segments. Then we can have our route map. What's the name? OSPF to BGP, right? We just studied that. Permits, let's say 0. Permits 0. Then match IP address prefix list internal, right? Internal. Okay. So after that, you can deny that stuffs. Deny other stuffs after that. Okay, so that's fine. So one more thing, let's go into the BGP guide, right? Address family IPv4, right? So no distribute OSPF1. So let's do it properly. We distribute OSPF1 route map OSPF to BGP. Okay, so I believe this is fine now. This is fine. It was working before fine, but this way we can granularly control everything going on, so that if we have some subnet data we don't want to import to BGP, we can control it by ourselves. Okay, so I believe this section is good now. This section is good. So from 2.1 says the EIGRP adjacency between the integration router and the legacy COP router is not forming. Wow, why is that not forming? So between integration router, this guy and this guy, so EIGRP is running here. That's beautiful. So let's see what's going on. He said it's not forming. Let's just confirm. Show IP EIGRP, right? Neighbors. We can't see anything. Let's see what's going on. What's going on in EIGRP? So we have the network, we have Redistribution OSPF, we have distance. Okay, let's check on the other guy. Show run EIGRP. Right. So this guy, we're having passive interface default. So by default, it will not want to establish neighbor with someone else. So let's remove that. Router EIGRP. Let's remove that now. That's the issue. No passive interface default. Okay, we have the adjacency. So let's check. Do show IP EIGRP neighbor. Okay, that's fine. That's fine now. So we fixed that. Then from 2.2, the adjacencies are stable. Routes are not being correctly exchanged between the OSPF and EIGRP domains. Identify and fix the distinct distribution error of the integration router. Okay. So let's see what the integration. So the integration router is running OSPF and pairing with this guy. It's also running EIGRP and pairing with this guy. So it's the redistribution point in this scenario, in this case. So let's see how EIGRP is being distributed into OSPF, while OSPF is being distributed into EIGRP. Okay, so let's look at that. Show run one more time. Just one more time, I promise. Okay, on the integration router, we have something here. We have something here. Oh, what we know that according to EIGRP, what EIGRP does with this is that it imports this OSPF, but the routes are not stable. It just gives them an infinite metric. The routes are not stable because EIGRP wants once its stuffs are imported, you need to specify things like the bandwidth, the delay, the reliability, and all of that. Or you can just give it a default metric. You can give it a default metric to use to treat how imported routes will be. So like this, as we're importing this OSPF, it gives it an infinite metric, and that route is unstable and useless, unusable. So what we can do is to either give it a default metric that, oh yeah, see your guy, when you import OSPF, give it this default metric, or we can change this distribute command such that it's going to have all those other parameters it needs to be able to be stable, like the bandwidth, the MTU, the loads, and all of that. So let's do that. EIGRP router EIGRP1. So first of all, let me remove this. Now let's do it again. To distribute OSPF1. Is that even the correct OSPF? Yeah. Distribute OSPF1. Now we have to specify. Okay, let's use question mark. So we have to specify what was this metric? So you see, we have to specify the metric for the distributed route. So question mark again. So we have to specify what the bandwidth of this. So let's give it 10,000. This bandwidth is in kilobits per second. So kilobits per second. So let's do again. Question mark. We have to specify the delay. We have to specify the delay in microseconds. So they can give it 100. Question mark again. We have to specify the reliability. Where 255 is more reliable. It's 100% reliable. So let's give it 255 now. So that's fine. Question mark again. We can specify the load. We can specify the load where 255 is 100% loaded. No, they don't want this link to look as if it is 100% loaded, so that traffic cannot pass through it beautifully. So let's give it a lower load of 1. Let's do our question mark again. Now the EIGRP MTU, the maximum transmission unit, let's give it at 15. Question mark again. So we see we can hit our enter now. So let's do that. So just a recap of on what we did. We have to specify the metric. We have to specify the metric or give it a default metric where that EIGRP is going to use for imported routes. So in this case, we gave it those metrics manually. We gave it the bandwidth, we gave it the delay, we gave it the reliability of the route where the higher the better. We gave it the load of that route where the lower the better. We gave it the empty. So that is fine. So the routes are not correctly exchanged between. Let's see if the routes can be exchanged now. So let's go to our NC. First of all, our LC core. What are you doing? Show IP interface brief. So I believe this is the route we need. This is the internal route we did. Going to E000. Going here. B.1Q. Okay. So let's see if we can see that route from our NC distribution now. Now that we've done our redistribution stuffs. Oh yeah, so we are learning it via OSPF, external routes. So can we reach it? Beautiful, we can reach it. Let's confirm. Let's see from this NC core, can we reach the internet? Okay, from the NC core we can't reach the internet yet. Yeah, that's fine. Let's see. Let's continue working. Let's check the other one. Okay, let's examine its routing table. Do show IP routes. Do show IP routes. We have the routes. We have the routes on this routing table via 10.0.7.1. I believe that's the integration router. Yep, E01. Yes, so that's the integration router. Can the integration router reach those places? Okay. Let's see what's going on here. This has lent its property. Due to our prefix import we did the other time. So let's see. Okay, so pinging it from the source, because of course you can see we are learning via the source. So pinging from the source, we can actually reach the ISPs. So let's try the second one. Okay, so that's fine. So the communication has been established from this LC core up to the ISPs. Let's see if it's. I believe it has been established from this LC core up to the NC core also, because the other end would ping the other time. So ping 192.168.1.1. So that's established. That's fine. I believe 100 is the PC. Let's try to ping the PC. Okay. That's the NCPC right here, but that's not a problem. We'll get back to that later. I don't even know if IP is configured on this PC yet, but we'll check that later. Okay, let's just continue. And so remember, as you do anything, as you finish for each prompt, you document it, because you are going to submit the PDF. You convert this to PDF and submit at the end. That's the only thing you have to submit. I saw some solutions whereby you did not really follow this format, though it was specified that you need to follow this format. I think some persons posted just the configurations all through. I think that was in the foundation track. Why in this expert track, I think I saw a submission that was I did not really see it in this format. It was just more of like screenshots and stuff like that. But I actually want to see this format. I want to see the commands you ran to get those screenshots. I want to see how you can describe the fault that happened. Because those are like what I actually want to see, not just the command. But for that first challenge, I just like graded it normal based on what I could still see and all of that. But from subsequent ones, let's try to follow the format properly. Okay, so 3.1, an L2 object has been revealed the connectivity failure between the new COP device, NC, this is one, and the access layer is, so there's an issue here. Oh, okay, maybe that's one of the reasons why we could not even ping from here just now. Okay, that's fine. So identify and resolve this layer 2 issue. So they say this issue is between NC distribution and NC users. So let's see what's going on. Show IP interface proof. Let's just have a proper examination. So we know that this is the interface going down. Yeah, that's the interface going down. So there should be a form of .1 queue. That's the plan. So the gateway is this. The gateway is on the router. Fine. So let's see the configuration. So we have encapsulation.1 queue native. Okay, they're using VLAN 1. Okay, that's not very good. It's not good to use the default VLAN, but let's keep it that way. For this end, I think the configuration on this end looks fine. It looks fine. We have the encapsulation native, we have the proper IP, and it's properly on the sub interface. Let's check the NC users. So the interface is E0/0. Let's see what's going on here. Show run. Just a minute, is this supposed to be access? I don't think this is supposed to be access. This is facing the .1 queue interface right here. So this should be a trunk. Why this down here should be access? So let's fix that. Config C E0/0 switch port mode trunk. So that's fine. Okay. We have some stuff going on. Why this one coming down here, E0/1 should be access. E01 should be access. Do we have anything on E01? There is no configuration there. Okay, let's jump into our NC and see what we have. So how do we check our IP here? We don't really know. Show. Let's check show IP. Okay. So we can say our IP is not set yet. So let's do 192.168.1.100, I believe. Okay, it's not stated, so we can give it something within that subnet. Okay, 255.255.255.0, then the gateway is .1. Okay, let's see if we can reach the gateway. We'll see if what we've done is okay. So we can reach the gateway. So everything is fine. Let's see if we can reach the other. We know this is right. 2.1. 2.1 is this guy. For this subnet down here. So let's see if we can get there. That's beautiful. Let's see if we can reach 8.8. That's fine. And let's see if we can reach 9.9. I think that's good. So we've been able to fix this issue. Now on this LC, let's see show IP. Do we have IP? No IP. So let's set the IP. IP address 192.168.2.100.255.255.0 Okay, invalid IP. Why? 192.168.2.100.2.1. Is it that I'm not saying clearly, or there is an issue somewhere? IP. Okay. I think we don't need this address. Yeah, we don't need the address command right there. Okay, let's see if we can reach the gateway. 2.1, right? We can reach the gateway, so everything is fine. Let's see if we can reach the other PC. This PC down here. Okay. Beautiful, right? So let's see if we can reach the internet. So we can reach the first internet. Let's check the second one. Beautiful. So everything is fine. However, there is one more thing here. It has been reported that an engineer has left a note on NC Core 1. It is big that this is a critical piece of information. You will know it when you see it. It has the format ANC. You need to submit the contents of that flag. So where NC Core 1, right? Okay. So to address this, there is no specific thing you should do to get this. You just have to look for the information. You have to dig in to look for the information. So the first thing I would do is to maybe check the directory distance and see if there are interesting files here that I can read. I think I can use the more, right here. I can use the more command to display contents of files. So I can say more CME is a directory because of the T right here. So let's check the default running config. This is even 0. This is not, there's nothing, but let's check to read this. So we see with that command we can actually read the contents of the file and all of that. But just looking at this, I don't think anything looks interesting yet. But we should also note that there are different directories, not just the default one. This default one is on the system directory. So there are other ones. We can use /all to see all files. We can just use /all to see all files, but I think nothing much changed. Nothing much changed right here. So you can dig in and check for things that are not regular. And I think my eyes just spotted one right here. This description on loopback 1000. What is this? This is not how description looks like. This is how a good description looks like. But what really is this? Let's see. Let's dig in and see. To me, this looks, because I have some experience and knowledge on this, so this looks like an encoded message. This is an encoded message. There are some sites where you can go to and just paste this message, and it's going to tell you whether this one is in base XYZ or base ABC, or this is a Morse code, or whatever form of encoding it is. So you can do some search to get those sites, because you don't know what will come up in subsequent challenges, right? So, but for this, let's just redirect. I already know this is base 64, so I have a base 64 decoder right here. So I paste this in and decode it. Okay, so this is the flag. So all we just need to do is to copy this, and paste it. That's all for that section. That's all for that point. So we see it's even given us an int, iBGP split, horizon synchronization, and all of that. So maybe if you got stuck here, I don't expect you to keep staying here and hosting all the time. Then at the point where you get here, this so it's even stated that the flag, it might help your troubleshooting also. So that's this right here might ring a bell that okay, maybe something going on here is relating to this, and maybe from there you can be able to fix it. Remember the maybe BGP redistribute internal command and all of that. So that's the end for this. Okay, that's not the end. We have 2 turns left in verification. So provide the output of a successful trace route from a host on NC COP to a host on the legacy COP. So let's see. So trace, is it trace route? Is that the command? Let's see. 192.168.2.100. Okay, so let's try trace. Okay, so I think that's fine. So we can see it hits its gateway. It hits its gateway. It gets to it gets to the integration router. It gets to the LC core, and finally it gets to the device in question. Okay. So that's fine. So what's next? Provide the output of show IP routes from NC distribution 1, confirming that it has learned 8.8 and 9.9. I think we've sent that before. And now I don't know how to drag this thing back down. I don't know how to drag this thing back down. I've taken it up so much. Okay, so we're in the NC core right now. Oh, from the NC distribution. Sorry, not NC core. NC distribution. Okay, so show IP routes. Good. So we can see show IP routes. We can see that we are learning the necessary stuffs. By the necessary stuff, so we can always take a screenshot of this. We can always take a screenshot and paste in our answers in the verification section. Okay. So after that, after everything is done, we have to convert this into a PDF. It's very easy. If you're on Windows, you can just Ctrl P and make sure you select print to PDF and you print it. Or you come over to the export session here. You
you click the create PDF, XPS documents, then create PDF. Then when you are done, that is the document you are going to submit. That's the only document you are going to submit. All right, thank you so much for joining this session, and we're going to see another time, even as we prepare for the next challenge. Thank you and bye.